Hey folks, so I wanted to create a video going over the 2020 sample question that the College Board released. So I'm just going to read through the question first. Students at an agricultural station conducted a study to compare genetically modified GM corn with regular corn. Each of 33 plots of lands was divided into two half plots. One half plot was randomly selected to be planted with the GM corn, and the other half plot was planted with regular corn. And this table shows summary statistics for the yields in bushels per acre and the difference in yield GM minus regular for each plot. Explain why the yields from one type of corn are not independent of the yields from another type of corn. So the reason that we're going to say that they're not independent actually comes from this portion, which is the plots of land were divided into two half plots, and then we randomly selected one half to plant regular corn and one half to plant genetically modified corn. So I'm going to write this out. The fact that the plots, or the two types of corn, are planted in the same plot confounds corn varietal with factors like, to give an example, like we'll say soil nutrition. All right, so there's part A. Let's move on to part B. Based on the summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of genetically modified corn or a plot of regular corn, and justify your answer? So this one I'll say, my first intuition was to go, okay, well, let's say yield of, let's call X, that's my yield of corn. And I want to find the probability X for genetically modified greater than 123, and also the probability that X for regular corn is greater than 123. And I might think, okay, I can just use normal CDF to do this. They're kind of trying to, this is a little bit of a gotcha question. I think they're trying to make you think that that's okay to do. But if we go back, there's nothing stated in the prompt about the distribution of corn yields for either of these. So we can't assume that it's a normal distribution. So we're going to nix that, and all I'm going to say is more likely to receive a yield actually, hold on, I'll pause the video and then write it out and explain it. It says it's more likely to receive a yield greater than 123 with genetically modified corn because GM yield sits above 125, and its median is 127.5, meaning over half the plots yield more than that. Regular corn has a median around 119, so it must be the case that less than half the plots yield above 123. Okay, a box plot of the differences in yields is shown below. Describe the distribution of differences. So this is just a straightforward SOX question where you want to make sure you describe shape, center, spread, any outliers. There does seem to be one outlier in this case. And then also add context. So I'll write it out and then we'll read through it. Box plot of the differences in yield is shown below. So what I said was the distribution of differences in corn yield, GM minus regular, has a median of 3.0 with an IQR of 6.9 bushels. The shape has a strong right skew with potential outlier yield of 20.1 bushels per acre. So shape, center, spread, outliers and context. In this case, I made specific use of the median because that's what a box plot shows us. And I used IQR because this has a skew, and so IQR as a measure of spread, remember, is resistant to skew and outliers. All right, and we added context to that, which is bushels. Moving on. Here, the students conducted a test of the hypothesis. The null hypothesis is that the mu difference is 0, and the alternative is mu difference is not 0, where mu difference is the population mean difference, GM minus regular, in yields in bushels per acre for plots similar to those used in the study. The conditions for inference have been met. One of the conditions for inference that was met was the sample size of the difference is greater than 30. So this is the large counts condition for a mean. So explain why it's necessary to satisfy this condition. So we need this. This condition allows us to assume that the central limit theorem applies. And here's what the central limit theorem, it just says that as long as your sample size is large enough, then the sampling distribution that you're interested in will be approximately normal. The sampling distribution, whoops, I need an N. Of sample mean differences is, and you don't just want to say normal, you have to be very specific with your language on the AP exam, so we're going to say is approximately normal. Great. So the last part, the test resulted in a p-value of 0.0003. Based on this p-value, what conclusion should the students make? So really they need to give us a significance level, but remember we would normally use a significance level of around 5% or 1% depending. So either way, this is a very small p-value, and we're going to conclude we reject H null in favor of HA. We have significant evidence that the true mean difference, and then again I'm going to state the direction of that difference, in bushels per acre is different for genetically modified and regular corn. So I'm just using that script we learned for concluding a hypothesis test. So do it abstractly first and then add context second. Okay guys, I hope this helped.